In the previous video, we saw that the formula a over c plus b over c, we add the numerators a plus b, and we leave the denominator the same. It's very important that the denominators of these fractions are the same. This allows us to compare things that are the same size instead of being split up into different pieces. However, if the denominators are not the same, we have to do some extra work. Specifically, if we're trying to add fractions that don't have the same denominator, we have to change both of them to make the denominator the same. This process is called finding a common denominator, and we can think about it as unsimplifying a fraction in order to make the bottoms match. To be clear, anytime we're adding or subtracting fractions, we always need the denominator to be the same. So how do we do that? Well, let's learn by looking at this example. 1 over 2 plus 1 over 3, these are not the same. And so we cannot use our formula to just add the numerators. Rather, we have to make them the same. Make them the same. Now, the easiest way to do this is just by multiplying the denominator of one side by one number and multiplying the denominator by the other side by a different number so that whatever the answer is the same. And something that will always work is multiplying the denominator on one side by the denominator on the other. For example, if I multiply 3 by 2 and I multiply 2 by 3, then both of my denominators will be 6. That's great. However, we have to do one more thing, which is everything we do to the denominator of a number, we also have to do to the numerator. So when we multiply this 3 by 2, we also have to multiply this 1 by 2. That way, the answer that we get, which in this case would be 2/6, is actually the same as 1/3. Similarly, since we multiplied this 2 by 3, we also have to multiply its numerator by 3. So the answer that we get, 3 over 6, is the same thing as 1/2. We're not actually changing the expression, we're just rewriting it in a way that gives us a common denominator, in this case 6. And now that our denominator is the same, we can use the same process as before to add the numerators, leave the denominator as is, and we get the final answer is 5/6. 1/2 plus 1/3 is 5/6, and we got there by finding a common denominator. We have to do that every time. Let's try another example. 3/5 plus 7/10. Once again, our denominators are not the same, and so we can do the same technique that I suggested last time. We can multiply this numerator and denominator times 5, because there's a 5 here. We'll multiply this denominator and numerator times 10, since there's a 10 here. And then we can write down what remains. 3 times 10, that's 30/50, plus 7 times 5, 35/50, and we'll notice that we now have a common denominator. Once again, we can add the numerators, leave the denominator as is, and we get 65/50, and if we want, we can simplify that, always a good idea. If we divide both of these by 5, we get 13/10. Cool. Now, the technique we just used isn't necessarily the best one, because we ended up having to take these really big numbers in our final answer and simplify them. If we want, we can find a common denominator in another way in some cases. In this example, same as before, we have 3/5 plus 7/10, and we want to find a common denominator. Instead of multiplying our denominators together in order to find a common denominator, we can see if there are any smaller common denominators we could use. Specifically, we know that 10 is 5 times 2. We already have a 5 over here in our left denominator, and so if we multiply it by 2, that would give both our denominators 10. Once again, anything we do to the denominator, we also have to do to the numerator, and we don't have to do anything to this 7/10. We can leave it as is. In this case, 3/5 plus 7/10, if we multiply the first number by 2, that'll become 6/10 plus 7/10. And as before, 6 plus 7 over 10 gives us the exact same answer, 13/10, but with less work.